Hi there, Mr. Holcomb here with another lesson in pre-algebra. This is a lesson that is out of the supplemental book, Student Companion. So we're going to be in this for the next 4 days. And session one is applying exponent properties for positive integer exponents. So explore applying exponent properties for positive integer exponents. Previously, you learned how to evaluate powers. In this lesson, you'll learn ways to simplify expressions involving two or more powers. So let me just stop right there and just say, okay, if we had 2 to the fourth power, that just simply means 2 times 2 times 2 times 2, and that is 2 times 2 is 4 times 2 is 8 times 2 is 16. So what an exponent is, or power is repeated multiplication. Use what you know to try to solve the problem below. So it says, how can you write 10 to the third power, and then that whole thing squared as a single power of 10 that has one base and one exponent? So the way I would think about this is, well, 10 to the third is 10 times 10 times 10. Excuse me. And squaring it means to multiply it by itself one time, or two times actually. 10 times 10 times 10 again. So, and then how many 10s do I have? Well, there are 6 now. So 10 to the third squared would be 10 3 times, multiplied 3 times, and then a group of 3 twice, totaling, multiplying 10 by itself 6 times. Okay. So on to the next page, it says, look ahead. An expression like 10 to the 3 or 10 cubed and then squared is called a power of a power. Recall that a power is an expression with a base and an exponent. Okay, so we have a base and we have an exponent. Okay, you can write a power as a repeated multiplication. So there it is, repeated multiplication of the base when the exponent is a positive integer. The exponent tells you how many times the base is used as a factor. For example, -3 squared, let me highlight this. -3 squared means -3 times -3. So the first thing it asks us to do is write 10 to the third as a product of repeated factors. Well, the base is 10, and it's repeated 3 times. That's what the exponent tells us. So it's 10 times 10 times 10. Part B says, square the expression you wrote in problem 2A. Well, I wrote 10 times 10 times 10 in 2A. And in order to square that as a group, I'm going to put parentheses around it. So that's what this means. Well, that simply means 10 times 10 times 10 twice. 10 times 10 times 10. And I could put parentheses around these, if you will, just to show that it's two groups of 3 that we're multiplying. So write an answer, and it says write the answer as repeated multiplication. So there it is. How does the number of repeated factors changed? Well, it was 3. It was 3. And, oops, not B, A and B. And we multiplied the 3 by 2. Okay, so we're multiplying those 3 by this power of 2. Okay, so there were 3. 3 times 2, there are now 6. So part C says complete the table. We have 10 to the second power to the fifth power. So they have 10 twice grouped together. 10 squared is 10 times 10. And then we wrote it 5 times. Single power is, well, how many 10s are there now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 10 to the 10th power. This one was left blank. So what I'm going to do is I'm going to look in the parentheses, and there are 4. So it's going to be 10 to the fourth power. And then there are two parentheses, so the 2 goes outside. So there's two parentheses with 4 in each, totaling 8. Okay. And then this says 10 to the third power again. So that means 10 times 10 times 10. That'd be 10 to the third power if this was a 1, but it's a 3. So I have to do this 3 more times. So just to save time, I'm going to copy this twice. I'm going to put it here. I'm going to put it here. Okay. So then it's this. Okay. 10 to the third. There's just 3 10s multiplied, 10 times 10 times 10, and then do that 3 times. And now we have a total of 9 10s. Look at each row of the table in 2C. Look at each row. How are the exponents in the first column, this column, related to the exponent in the third column over here? So what I would say here is the exponent in the third column is the product of the exponents in the first column. Okay? The exponent in the third column is the product of the exponents in the first column. 2 times 5, 10. 4 times 2, 8. 3 times 3, 9. All right, so now it says reflect. How could you write -5 to the 7th power cubed as a single power of -5? So you take this power here. What do we do here? 2 times 5 gave us 10. So I'm going to show my work. It's going to be 7 times 3. And that's going to equal -5 to the 21. There is a single power of -5. Okay. Prepare for applying exponent properties for positive integer exponents. Think about what you know about powers and exponents. Fill in each box. Use words, numbers, and pictures. Show as many ideas as you can. I'm going to leave this to the viewer. We did these in class together, and I always like the students to think about this, give examples so that we can put them in here. So I'm going to leave that to the viewer if they're working on this for an assignment. Number 2 says, write each power as a product of repeated factors. Okay, that's the first thing we're going to do. Let me highlight that. Write each power as a product of repeated factors. So this would be the base multiplied 3 times because my exponent is 3. My base over here is 10, and the exponent is 4. So it's 10 times 10 times 10 times 10. For C, it's 0.8 twice. Okay, so I just did that part. But now it says evaluate. Evaluate means find the value of this. So when I do this one here, we're multiplying straight across. The numerator times the numerator times the numerator. 1 times 1 times 1 is 1. 3 times 3 is 9 times 3 is 27. So the answer is 1 over 27. So I'm going to point something out to you here. If you have a fraction in a parentheses with an exponent, what we do is we take this exponent and we distribute it inside like so. Okay, so 1 cubed or 1 to the third power is 1, and 3 to the third power is 27. All right, this one, 10 times 10 times 10 times 10 is 1 with 4 zeros. And 4 zeros is 10,000. 8 times 8 is 64, and there's 2 decimal places, so the decimal goes here. So 0.8 or 8/10 squared is 0.64 or 64 100ths. Right, next page. Session 1, additional practice. 3A. How can you write 10 squared, all to the 4th power, as a single power of 10? Well, it's 10 to the 2 times 4, which is 10 to the 8. Alrighty. So now it says, check your answer to problem 3A. Show your work. So here's how I would check my answer. 10 squared to the 4th power means 10 times 10, right? That's 10 squared. And I do that 4 times. There's 2. Here's 3. And here's 4. And then count my tens. So there's 1, 2, 3, 4, 5, 6, 7, 8 tens. So this is 10 to the power of 8, and it checks. Okay, so that's the end of this lesson. Thanks for watching, and have a great day.